This video is about measures of variation. To know about what variation is, let's look at the graph over here. This shows the wait time of a business in single line or in multiple lines. You can see when people wait in a single line, the wait time are about the same, right? They're all about 100 seconds. Right? We have like several around 90, I would say 97, several around 98, 99, and quite a few around 100 seconds and 100 and 1 or 2 seconds, and one is 103 seconds. That's for the single line. But whereas for multiple lines, you can see the wait time, they are all over the place. Some are around 80, 84, 85, and the maximum wait time will be 125. These two sets of data actually have the same mean. The mean on the top data is 100 seconds, and the mean of the bottom data is also 100 seconds. So what is the difference here? The difference is the variation. The top data actually have less of a variation because all the data values are close up together. The bottom data has more of a variation because the data values are all over the place. The most common thing we use to measure variation is called standard deviation. It measures how much data values deviate away from the mean. We use S for sample standard deviation. So to find the standard deviation of the sample, we use this formula. Square root of the sum of all the x minus x bar, here means the mean, squared, divided by n minus 1. Okay, so just a quick reminder, the x here represent the individual data values, and x bar here is the sample mean, where n is the sample size, meaning how many data values are there in the data. Now let's look at one example. Say for a math class, the final scores, I picked 5 final scores. Right? There's 65, 70, 75, 80, 80. So I have a sample of 5 values. So now I want to find the standard deviation of the sample. That means I have to use this formula. Okay, so first I will have to find the mean. I have to use this value here. So I want to find the sample mean. Right, to find the sample mean, you add up all the numbers and divide it by the sample size, in this case is 5, and do the calculation. So using my calculator, the top add up to 370 divided by 5. The answer is 74. So that is the mean of my sample. So to find the standard deviation, now I need to find each x minus x bar. Right, so I am going to make a chart over here. Right, so all my x's over here. The x's are 65, 70, 75, 80, 80, right? So for each x minus the sample mean, I'll have 65 minus 74, which is negative 9, right? Then I have 70 minus 74, negative 4, 75 minus 74, which is 1. 80 minus 74, this is a 6, and this is another 6. Then you have to square it. Okay, so here I will change it to squared. So overall you have, what is the value? 81, right? That's negative 9 squared. Negative 4 squared, 16. And 1 squared, 1. 6 squared, 36. And 6 squared, 36. Now, remember what this sign means? It means the sum of. Then we add up all the values of x minus x bar. So add them up. You have, using my calculator, I will have, okay, the sum of all these values, I just did the calculation, is 170. Okay, so let me write down the formula again. Square root of the sum of all the x minus x bar squared divided by n minus 1. Okay, so square root of, we already know this whole top part. That's 170. And n is the sample size. So that's 5 minus 1, that's 4. So using the calculator, 170 divided by 4, that's 42.5. And that takes a square root . The answer is about, the answer is about 6.52. And this value is the sample standard deviation. So now what does the standard deviation do? One thing is we can use the standard deviation of a population or a sample to find if a single value is too high or too low in the sample or in the population. So here we'll introduce something called a range rule of thumb. Okay, so first of all, we know the population mean. Population mean is this symbol, read as mu, and the population standard deviation is sigma. Standard use this symbol. Okay. All right. So in the middle, it will be the mean, right? For a set of data, in the middle it will be the mean. All right. If your mean add up to 2 standard deviation, mu plus 2 sigma, any value above your mean plus 2 standard deviation is considered significantly high values. All right, so any value that is 2 standard deviation below the mean, so say this is the mean minus 2 standard deviation, any values below that is considered significantly low values. And the values in between mu minus 2 sigma and mu plus sigma, these values are considered values that are not significant. Say for a math exam, the mean of the scores is, let's say, is 75. And the standard deviation of the scores is, let's say, 8. Right, so in this case, any values that is 2 standard deviation above 75 will be considered significantly high values. So 75 plus 2 times 8, that's 75 plus 16, that will be 91. So any scores above 91 is considered significantly high. And any score that is below 2 standard deviation below 75 is considered significantly low. In this case, it will be 75 minus 2 times 8. That will be 75 minus 16, that is, what is it? 59. Right? So in this case, any values above 91 is called significantly high value. And any value that's below 59, it's significantly low. And if you score between 59 and 91, those are scores that are not significant. Say a student scored, like, let's say 90 in this exam. According to our mean and standard deviation, this 90 is not considered significantly high. It's pretty high, but it's not, statistically significantly high. It's still within 59 to 91. It's a score that is not considered significant. However, if a person scored, let's say, 55, which falls into this range, right? And 55 will be considered significantly low. Standard deviation is actually a very useful value. There's a rule called Empirical Rule. Okay, this works for a bell-shaped distribution, in other words, normal distribution, like this graph. And you can see 90 is, so here, 68% of the data values are within 1 standard deviation away from the mean. Actually, if you go 2 standard deviation above or below the mean, that will cover 95% of the data values. And if you go 3 standard deviation above or below the mean, that will cover 99% of the data, given your data is a normal distributed data set. Of course, you can use StatCrunch to calculate standard deviation. Remember the sample we had earlier? 65, 70, 75, 80, 80. Okay, now I will put that on StatCrunch. Put it in a column, and I can use StatCrunch to calculate the standard deviation. You go to Stat, and then Summary Stat. Since we put all the values in a column, we put columns, and click the column, which is variable 1. And what we are looking for is standard deviation. Click here. And then you just click compute. And here is 6.5. You can round it to 2, right? 6.52. This is how you use StatCrunch to find standard deviation.